Good morning. How are we doing today? I am trying to get these oh, the music stopped. Adjust your filters. Really? It says like 10 hours there. You're lying. Hmm. Strange. All right. So what I was looking for, and wow, I like it, but I think it's a little too much for the stream. See what happens. So I'm looking for key combos to have inlay hints appear. So what's this? What's going on there? Okay. Control Alt. I think that'll work. Interesting. All right. So Nature. There we go. And I don't know if Natter's still connected from yesterday. Let's see. No, it's not connected. All right. So what we are working on is the message text parsing. And we're going to be focusing on this Twitch message parser file today. We're using Chomsky, the library. And I did read up a little bit about this last night and started to work a little bit on this. So let's kind of look at some pieces. The first piece here is just a simple code test, right? Turn off the that over there. Good. We have our vector of chars that we're working with because we still need that index range, right, to be in the char space, our indices. We have our list of emotes, which I now think we're going to have to adjust. It's not going to be a vector. I think it's going to be a map of spans to emote info. Right? I think this needs to be span to emote ID. All right. So using Chomsky, we create our parser and then our kind of recovery method, right? So this will give us the stream and any errors it encountered along the way. Not all errors in Chomsky are fatal, so that's kind of interesting. So you might have a parser that can recover. So you'll have your maybe result, right, and your list of errors. Pass in the message, which is our vector of chars, and we get stuff back. In this case, we're getting back message part code, right, which is just let foo equals bar, right, and that's a string, and our, I guess we could probably flip this around. This is technically that. So it's some message code. That's what we're getting back, right? And if we look at how that is happening, scroll up a bit, and this is our message parser. First, so Chomsky is kind of like this recursive set of parsers, right? So you create a parser, and you can use the parser in other parsers, and it's like that old thing where you have turtles all the way down. In this case, it's parsers all the way down. So we declare that we just want a backtick, right? But it's repeated, right? So just is a parser, and then we say, oh, that has to be repeated, right? And that could be repeated 0 or more times, right? It's kind of like the regex regular expression asterisk. But then we can say, oh, but your repeated thing, we want exactly 3 of you. So this would give us that. So this is a parser that looks for exactly 3 backticks. And then if we're looking for a code block, which oh, come on, fingers. Wow, I gotta retrain myself. If we're looking for a code block, it's going to be a code fence. Then we take until we find another code fence, and we map that. It'll actually give us, it will give us, what is it? V is going to be fence, string, fence, right? So it'll give us this information that we have to then convert into our return type, our result type, which we have declared as being a message part. So our message part is our enum, our input, vector of chars, output, message parts. Our errors are using the simple char. And this is from Chomsky. Right? So it's fairly straightforward, right? Oh, this is technically a vec of char that we have to convert to a string here. Now Chomsky does have the ability to convert things into strings, but I'm not sure how to wire that up in this sequence. Mostly because I'm not certain how to let's look. Let's find the Chomsky bits. What do we got? All right, here's our documentation. Right. Bunch of different modules. We have primitive, right? where you will find a number of useful items here. Right, so take until, it's a sequence. Right, so you might have it's this iterator than that one, but that's deprecated. So if you want none of these, just this one, right, which is what we were using for the backtick. End. Parser that only accepts the end of the input, right? Which we're not using yet. Okay. But there are other things as well. If we look for string, that's not it. Huh. It's in here somewhere. It's either that or it got replaced with something. Maybe it's a 2 string? No? Anyhow. Sometimes you find documentation that's a little old. So I might be remembering that. If we look in the text, they have a text module. They have a couple of useful functions that produce parsers. So this is a parser for white space, for digits, for ident, which might be a language keyword, right? All right. So coming back here, this is how we constructed our code fence and our code block, and that test works. Right? Now, I was also looking at, how do we detect emoticons? Emoticons are a challenge because for us they are declared as information about a range or span in the string, right? In the list or the vector of chars. So for us, we don't have any sort of unique token that we can match. We have to match all the tokens and validate them based on the span. Okay. So I think Chomsky might just work for us. Basically, what we can do is create a parser that matches words, right? Things that are bordered by white space. Because in Twitch, you can't have like you can say hello kappa world, right? And that kappa has to be bordered by white space. If you said hello and then you had like exclamation kappa, let's see if this works. That still works. Oh no. Okay. So special characters. So my parser is already broken. Okay. So I was just testing on white space. Now, okay, so it might be just alphanumeric and underscore. What if hello underscore kappa? Okay, underscore is a no-go. All right, so we might have to search for only white or only alphanumeric. So basically, we're trying to create something that Chomsky can find that we would be able to validate the span of. Okay. Which allows special tokens next to emoticons. So we will use a filter, or a little filter parser, which will just let us specify what the rules are for a parser, so how it consumes tokens. And in this case, we need to adjust, because it's not just white. It's not just not white space. It will have to be C dot is alphanumeric. Might be enough. Okay. Should probably have a test for that. Now that we know that this works. All right. So it's a filter checking for an alphanumeric character that is repeated at least once. I expect that, you know, it could be more than once. Like our minimum for an emoticon might be 2, right? Because we might have like colon smiley, right? Like colon is not an emoticon. Colon smiley is, right? Colon capital D. So we could reduce the amount of work this does by having at least 2. Oh, and that's not going to work for us as an emoticon, is it? Oh, shenanigans, because colon D, those two characters together, right? We just found an error in our test. Alphanumeric or colon. What if we did like a? No, that's not one. Okay. Yeah, this is going to be problematic for us. I can tell. Like the rules for identifying what an emoticon span are, because we basically have to identify the emoticons, these words, and without having the master list of all the possible text tokens, we have to get close enough. All right, at least 2 of those. So basically we create this parser. It's repeated at least twice, but then we get to validate it. We could say, oh, you know what? We're not going to be looking at the chars that you found, but we're going to be looking at the span. So if we change this emotes to be a hash map of span to emote ID, we could simply look it up here, check to see if it's in there, and reject it. So we'll emit an error saying this is not an emote. Otherwise, we return the chars and map those, or we can return whatever we want here. So this could be the identifier for the emote that then gets passed to map, and we can map that into an emoticon. I think we could really let's see, does this allow us to do the mapping? It does. So we could do the mapping entirely inside of validate. There. Now, the third thing we have to identify is our text. Right? And our text is something, it's basically everything else. So primitive, any, repeated at least once. I don't know if this should just be repeated or repeated at least once. I didn't think that it would be very useful to have a block of 0 text. So I said at least once, and then we convert that into a string. Now, was there flatten? Interesting. Okay. Parsers are kind of like iterators. Okay. Now, given that, this test here, it works. Okay. Hello, this is a test. Our text one, this one, let's see if this works. It does. Okay. However, no, this is where things get a little interesting here. We didn't talk about how we combined these at the end. So I said, if it's a code block or emoticon or text, hoping to set up some precedence here. And then we have hello, and then a code block, and then text. Because we are erroring on every emoticon currently. And if we run this, it fails. So we're expecting expecting 3 blocks actually. So we received hello, this is a test, right, with the code block removed from it. That's interesting. That's neat. Okay, so it actually found the code block and stripped it out. No. That's that's me being goofy. Okay. This is our expected text, and this is what we got back. So it did not find the code block. It just gave us that straight back. Okay. So how do we get this? How do we convert or configure this? We just say that, oh, it's repeated. And then it's not... then... end? So we look for a code block or emoticon or text, we repeat that, and then there's the end. Go test. Oh, we have an error up here. Trait bound. Whoa, that's the other thing I've seen about with Chomsky. Sometimes the errors can get a little verbose. Okay. The trait message part is not implemented for... Okay. Trait bound. Basically, this is our structure that we've set up. I'm going to close that. Was it because of the end and the then piece? think it's because we're not mapping something, but I'm not sure what. Oh, and I minimized that. I've been doing that instead of closing the problems panel, minimizing the whole thing. Both make the problems go away. Okay. I want to see what this is. They also have a to-do parser. So in case you don't know what something is at the moment. So here we're getting a vector of message part, which seems realistic. Are we supposed to say this should be a vector of message part? Is that what's going on? Yes, okay. Unused doc comment. Oh, my mistake. Okay. Now our parts are basically the wrong kind because we were expecting just a message part. Now we're getting an option to a vector of message part. Hey, good morning. How you doing, Emil? Welcome. And this should be some. No, this is. There we go. All right. I want to rename that to parts. Let's try it again. Let's see what we get now. Okay, still we get one text node. I think what's happening is that it's getting into this text mode, like this text element here, and it's just consuming all the text, right? Because they're greedy. Or it's lazy, is what they were calling it. Here is their example of a parser. Limited by. Oh, look at that. I didn't see that one. Oh, I want to see that one. Interesting. Parse the pattern surrounded by the given delimiters. We don't have a recursive parser. Maybe it is actually. And I've been thinking about it kind of in a flat way. Maybe it's all text, but in some of the text, we have these other things. I don't think it is, right? It's more of a list. It's either text, code, or emoji, emoticon. I've been using those interchangeably. On their brain, their BF example. BF delimited by is BF a stream here? I haven't looked at recursive yet. That seems like it's an option. And is it used? Sorry, just thinking about delimited by a bit more. This is on parser. Okay. We could identify text. So let's bring text up here. Text is just anything, right? And a code block, we could say, is, let's see, we'll need the fence. Limited by code fence. We have to map that into, what is it? This here. But we don't have the nested structure now, because it's just the middle element, right? Oh, V is a message part? It can't be a message part. I haven't converted it to anything. I see. Actually, I don't see. So delimited by start, end. Oh, it gives us going to say that this is text. And then we can just convert the text one, text block, into text block dot, I don't know, what's dot zero? Do structure here. Message part. Text. I don't think we can. Yeah, not covered. Which makes sense because it doesn't know which variant is coming in here. So it's one of these variants coming in. And in this case, we want to change the type of it, because we know what type it is. So how do we do that? We just match it? What do we do on error? What if it sends us the wrong kind? Oh, interesting. We could just handle every... Actually, if it's code already, yeah, whatever. So we could try that instead of this one. I want to see that blow up. Panicked assertion. Okay. Same thing still. It's not parsing this chunk here, which is fine. Simple code failed. Oh, interesting. Yeah, it didn't identify the code. Code block or emoticon or text repeated. Huh. Parse the pattern surrounded by the given delimiters. Oh, just for fun, I want to remove text out of there. See what happens. Okay, simple text failed. Perfect. Simple code still. This one. Oh, interesting. It's empty. I keep thinking that it's like a regular expression, right? Where we have to tell it, go all the way to the end. But it should just keep going until it's found something. But in this case, I think our code block just isn't matching. This delimited by on the text. So I think it's coming up with a text block. Or maybe we need to say, oh, you know what, this here is a code fence. Oh, I see. Am I trying to do too much in the parser? Because we're building an AST here. I happen to want to catch anything that's not, the backtick and this other stuff. I think it should work. Hey, I want to look at one of their examples. We have. Okay, this is their JSON parser. So they do parse a string. Up a little for the stream. It's recursive because JSON's recursive. Should ours be recursive? That's continually at the back of my mind here. We're producing a tree, right? And a tree should be maybe we're missing something like a top level message, right? Or something that holds everything else. Fractions, exponents, number, right? And chain parsers together. Collect into a string. Oh, you know what? That's what I was missing. We parse it into, so this is a number from string, okay. Escape. And our string, just quote. Okay, so this is similar to our fence. Right? So we have our fence, and then ignore then. Alter or I see. So ignore then is this whole section from here to here. And this is where we're ignoring escaped double quotes, etc. Ignore then, just double quote. Do we need to ignore then anything for the fence? I don't think so. We should just be able to collect it into a string. In their case, this string, where do they map that into a stir? Okay, so here, this is just how they identify a string. Number. Okay. So this is for their object, right? An object is strings to anything. And this is what they're doing at the very end, right? It's null. So we convert that to null, label it as null, or it's true, or it's false. So these are the JSON kind of primitives. Or it's a number, or it's a string that we map to stir. Okay. Interesting that they keep their kind of identifying parsers separate from where they map them into something. That's nice. Or it's an array, or it's an object. Cover with, okay. And this whole thing, it's recursive, then ignore, all the way to the end, recover with, yep, okay. So they ignore everything until the end once they've parsed everything. I like how they're identifying these different pieces, right? And then mapping them at the end. I want to try converting that as well. As text. See, I think this is wrong. So we have our code fence, which we can identify. We have a code block. code can be anything in this example because it's just text. And this isn't very structured, it's rather freeform. We're just trying to extract pieces out of it. I'm gonna rename this to anything. Let's get rid of that. It's anything. Ah, look, here we go. Now this is vector of chars. Nice. Code block. That's just too much elevator. All right, let's try that. Now, see, we don't have this kind of top level object or... So I was looking for code block first. I was like, oh, boom, if it's code block, great. We can map that into what... Let me just give it the... Hold on, where is it? Oh. Okay, this expects a stir, but I think it's getting something else. I mismatch, yes. Yeah. Huh. How are they doing that? Because they had a vector of strings as well. Oh, they collect and label. Huh. Well, let's do that. Still work there? No, because it's already an anything. Excuse me, already a string. Anything is. Okay, or emoticon. So we should really be returning whatever that identifier is here. Music is so dramatic. It's like the intro to some 70s film. Right. Oh, expected function signature. Oh, because I returned a stir there. Where is that? Okay. So I have code block. I like the mapping better down here. That's really nice. All right, I don't think we changed anything here. Let's double check though. Yeah, still the 3 failures. You know what we could do? Chris, how you doing? Oh, we're only doing those 3. Okay. Now, in this case, I would like to look at the errors. I have not been messing with ChatGPT so far. I've seen it on other channels. It's pretty entertaining. Okay. So for our first one, let's analyze the failure. Because I think even this one was failing. You lost track of time messing with it? Yeah. Where's our error? We should have had an error, like a DBG error. Where is this? 73. Oh, it's here. There is no error. I think what we're missing here is the top level, like the message. The message should be a vector message part. Right. Why isn't it just matching anything for the code block piece? Because we ended up with absolutely nothing for the code. Is that a tenor or a baritone sax? Sounds more tenor to me. Yeah, okay. Anyhow, getting lost in music. Wow, that normally doesn't happen to me. Gonna pour some tea. Okay. I think we should simplify, get it to work, and then build on it. some tea. Yeah, no, not this music. That's too much. Here. All right. So this thing I'm expecting should be able to find this, right? And we don't know why it's not finding that. So let's just have it look for that one thing, right? Now it's only looking for code block. Emoticon isn't even wired up. It should be telling us that emoticon's not used, but it's not. Huh. Okay. Oh, it's got some other error. Oh, and this needs to be repeated. Okay. Now we have a vector. Now. Okay, good. It's still not a... I think our... Either something's broken... Where are we? In our anything? Or... Because I would rather have this thing error out when it can't parse this. And skip, then retry until... What is this? I'm not familiar with this one. Oh, recovery. Oh, let's look in the recovery section. Skips to the next input on parser failure and then tries again. Interesting. Huh. Gonna toss this on there. Could go wrong. So repeated, then we ignore up until the end, but then ignores kind of special. Parse one thing and then the other thing, yielding the output of the former, right? Which is fine, because the other thing in this case is end, and we're not going to want that. Let's see if we can get it to force an error. Oh, look at this. Oh, we did get it to force an error. Because now we're asking it to match the end, and it can't. Okay. Ooh, I like this. A different one. The error, simple span. So the first character, it's unexpected. Really? Expected? Nothing. Found something. Really? Okay. Okay, I must have this delimited by misunderstood. Because I was thinking that it would be okay looking for a code fence, and then anything could be inside of that, right? But if it can't find, or if it's finding that a backtick is unexpected, that's unfortunate. Huh. Okay, let's. I think anything. Remove that repeated. Yeah, same error. Block. We map that to there. Repeated. Okay. Now what I had before was this one, right? We're not going to map that yet. See, and this is where like a code fence. Now the mapping part is going to break, right? Yeah, because it's giving us a tuple of tuples, right? I wonder why. Let's figure that out. Why is it getting us a tuple of tuples? Ah, because we're using a then, take until. So it's the code fence, it's identifying that. And take until gives us the body and then the other fence. Interesting. We need to... We don't need to collect a code fence. We just need to know that it exists. Hey, good morning, Handle. How you doing? And where am I playing Rust? Yeah, I'm programming Rust. There's a difference. Does look like a fun game though. Although I was more into the forest, you know. Am I a developer of Rust? I'm not. I presume still that you're talking about the game. Which this is not related to the game. In fact, this is in the, what is it? Software development? Where are we? Software and game development. Yeah. But no. not related to the game. Let's see. Oh, it's still going to fail because we didn't do the mapping correct. See, this one, I feel like if we map this, B.0.1, right? Oh, what is this then? Vector of char. Oh, my mistake. I wanted that here. No field 1 on type vector of char. Oh, I want 1.0. There we go. Yes, it is a programming language, and it's at rustlang.org. It's great. Check it out. All right. And now this is still expecting, well, even though we map that, where did we map it? Here. We're mapping that to vector char global. Oh, we didn't collect that into a string? Temp annotations needed. Really? Huh. Wonder why. Cannot infer type I on the any. Oh, because it's not being used anywhere. Most likely. Let's comment that out. Okay. Simple code. All right, so we got the code working. Oh no. Okay. What did we do? How did we fix that? Code block, we mapped that to a string. What does... Oh, do we have... How do we group these? Yeah, recursive would be one way, but... Because I feel like repeated ends up being applied to the code block. And then if we had like a .or... Oh, I see. That would be the whole... Okay, that does work. What do I do now? I'm a software engineer. And right now we're actually working on this chat client here. We're working on parsing the messages so that the emoticons show up, and we're actually changing the way that the message parsing works. Because right now we can say, for example, that foo equals can toss some code in there, and it would highlight the code and color it, etc. Right? But we want to be able to use code fences, which would be the triple backtick instead of the single backtick. And so I was changing the way that it parses out the code blocks. Using a new library, we're using Chomsky. Let's add that to see. Okay, so that caused it to fail. Panicked. At repeated parser iterations succeeded, but consumed no inputs. Infinite loop. Okay. Because this is repeated at least once. Why not use the crate Twitch chat? Were you trolling us with am I playing Rust? We are using that crate. And it worked. So we were able to get, okay, our simple code and simple text working. Yeah, this is using Tauri, which is like Electron, just with a Rust backend. And it's lighter. It uses whatever the system web view is. But we are using Twitch chat. It's used. We use Twitch chat in here. And that's how we're getting your message right now to show up on the screen. Twitch chat is connected to Twitch IRC, etc. Okay. So we have the first two tests working. Now let's add the... How do we get the third test working? What am I parsing? We are parsing the messages that come in from Twitch chat so that we can highlight them in code up here. All right. So let's correct our test. What do we expect to see here? We expect to see hello. Okay. Okay. And this code should be and commas. So this is what we're expecting. We want some text, code, then text. Okay, and we are just getting text back. It's not stopping at the triple backtick. Okay, so how do we get it to do that? Because it seems like with our other tests, if we just start out with one or the other, it works fine. But our anything seems a little aggressive. Feels like it should be anything as long as it's not a code block. And how did they do that in the JSON parser? Okay, here's their escape. So they're using ignore then. I wonder if there's like an opposite of that. How do we chain these together? So in this case, it's null, or true, or false, number, string, an object, an array. These recurse. Right. Yeah, that's a member and a member. Value. The tea might be cool enough to drink now. Nope. That's hot. Or not. Interesting. What's or not? Attempt to parse something, but only if it exists. Huh. Interesting. Order question. I see. I don't think that's all that useful, though, for this. It's interesting. I think we just need to use, like, a... repeated at least once. I think we need to use a filter. Filter parser that accepts only input that matches a given predicate. What if... What if we did the anything until other things, right? Like, wasn't there something in here for stopping as something else? Map with, or else padded by parse. Then okay, maybe then. By all right. So if we had anything here, and we said that we're repeating, like anything, the any character, right? Like the everything, we repeat it at least once. Then we have, and this is some other thing. Okay, this would be we have code, a code block, or not. And this feels like it gets into we kind of want like a code block dot or emoticon or not, right? $56. Oh, here, yeah. We can't collect that. That's fine. But we don't know if that's going to be an emoticon or a code block. Ooh. Maybe we don't collect those into strings yet. Code block. Let's just not collect that. So we have a code block, then we'll have like an emoticon, and then anything or something else, right? I wonder if we could just do it, if we could flip this, right? Let's say, what if we had anything? So instead of doing this here, I'm going to undo a bit. still want to collect those into strings. Okay. Anything then? And then we want basically this. Code block or message part. Let's see, then. And this should be emoticon. Telling us that it'll go on forever. Oh, there's an error. Expected. Oh, I see. Saying that we're going to get a tuple back because of the then. Ah, I did it again. I don't, yeah. All right, we'll make it through this. Learning Chomsky. They did have a tutorial as well, but I think the tutorial was much more focused on parsing stuff that was more structured. It's a tutorial. We haven't really looked at hold on this. That was here, right? Instead of mapping, we could hold R. And this would take the right-hand side, which is the tuple, drop that down. I don't know. No, it's not quite the same, is it? Because in this case, the structure looks similar. It's not quite. And it would only do it once. It's basically that. Okay. Hold L, pressing parentheses. This is similar to what we're doing with the code blocks, the code fences. An int atom, int or expression. This is interesting. Expression multiply as that function. Huh. Oh, wow. Oh, that started at the beginning. No. Go back to where I was. We might be able to do this in such a way where we have text, and text is always that, and then, or I don't know, what I'm trying to do here is actually what I'm doing with message, right? Where we just have different message parts. It's recursive. What I was really thinking was that it was like bring and then box message part, something like that, right? And not this, to where you always have some sort of text because it's a message, right? And then you either have, you know, emoticon or code after that. All right. I love that you have like a little video hosting platform. What is this? That's cool. I've never seen that website before. Oh, YouTube proxy front end. Gotcha. Oh, that makes more sense. Okay. That's cool. I'm gonna check my calendar real quick. We did it this way, where the whole thing was recursive. Then we'd have text blocks, but this doesn't really give us like this only gives us a list, right? Which I think we currently have. With this, I was trying to get this to flatten. We can't flatten string message part. Oh, come on. You know you could flatten that. Huh. Nice. Yeah, that's going to map the whole thing. No. So what we're getting here is string and then message part instead of the whole thing just being a vector of message part. What we want is vec message part, and what we're getting is string message part. Is that what it's saying? We expected blah blah blah. Yeah, I don't want a vector of tuples like this. I want this to be a message part, and that for it to be two separate pieces. How does flatten work? Do they even have flat map on their parser? Oh, they have chain. Oh, we could chain. Look at this. Attempting to chain the two outputs into a vec. Okay. Yeah, this is all in Chomsky, so they have their own sort of iterator-like functions. I wonder how many things we can chain together. What's it saying? It's not implemented for string. Oh, I see. So we need to map it first and then string. Okay. Expected struct. Vector of vector. Oh, wait, why? Because we didn't flatten? Okay, that looks better. Is everything broken? Yes, it's all broken. Okay. We're back to the unexpected none. Okay. Unexpected. Expected nothing. Oh, I feel like I could have hacked this out without Chomsky by now. Okay. But it's interesting to learn. Those are some low expectations. Absolutely. Expected nothing. Okay. The problem I was having was repeated at least one. Okay, let's add that back. So I think what it's expecting here, it wasn't matching it. Yeah, still. Like, why is that? Why is it expecting nothing, right? Anything, right? Match anything at least once. Collect that into a string. Then we want to chain. Or not. How do we say that these are optional? Okay, what happens if we just add that one or not there? Oh, simple text is now working. And because it's now optional here, but the code block is failing. And with the simple code, we're expecting a code block, but the text is matching everything. Do we invert this? Do we say, hey, let's look for a code block first, right? So anything should really be like the last choice. The problem we were having before was that when it got to the point of anything, it would just keep going. It would just keep consuming. And so it was like we really needed to say, okay, it can parse anything as long as it's not one of these other two things. Problem is anything doesn't have like an end, right? A bound. Maybe I'm looking at this kind of maybe this should be like word, right? So, and white space. Give it a chance to evaluate, kind of come up for air when it goes to toggle between them, so it could then switch over to code. But it might start with word and then go straight into code or something else. Really, I just want string to be like a catch-all. Like, look for emoticon, look for code. And if that character is not one of these other two things, I wonder if this would work if that was just a char, right? Like, don't collect, or yeah, just be that, right? It can be anything. All right, so we have a char, right? Just collect a char and chain these things and then repeat, right? Oh, we're yes, and then all of these. At this point, we'd need to look at the parts and then simplify it, right? So how about for this, We simply do a dbg part error and assert false. So we just want to see the output, right? Same here. All right. Now we're expecting things to fail so that we can inspect them. Custom not yet implemented. Interesting. Emoticon ID. Okay. Okay. Where's this silly emoticon thing? Yeah, each time it comes in here, it's going to say not yet implemented. Which is fine. It's just annoying. And why is it? Where's the top of this? Here it is. Okay, text and some code. So what are we looking at? Oh, text and code? Don't really want to look at that one yet. How about the last one? Simple code. Fine. Span 3 to 6. Oh, so those are the errors. Where's the... Was there no success for that? Yes, I see that we're rejecting a lot of stuff. Oh. Yeah, so we got backtick, blah, blah, blah. No idea. No idea. What if we didn't have... What if we didn't have anything? Let's get rid of that. And if that was the case, we would have code block. Code block mapped to that, or we'd have emoticons. Would repeat that, then we would ignore everything else to the end, right? What if we treated it as trying to find code blocks and emoticons, then everything else, we use these then ignore pieces, right? So we can say ignore then, and then I thought we were able to get both of the halves. Right? We were able to get the left and then the right. Maybe not. They have ignore until from start ignored. This is just white space, ignored, repeated. Okay. That's not what I want. I want something like delimited by, right, where we get both sides. then with. That's one thing, and then another thing, creating the second parser from the result of the first. Okay. I don't think that's what we want. Attempts to parse something, but only if it exists. Okay. Yeah, we were using that, or else. If both parsers succeed, the output of the first parser is guaranteed to be prioritized over the output of the second. Oh, choice instead. Okay. Okay. So prefer or unless the compile times are horrible, then use choice. Got it. Interesting. And this is what we want, right? If the first one succeeds, use it. Otherwise, the second one. All right. How do we say we want one, but only if it's not something else? That's really what we want. We could use filter. Where's filter? What's filter map? Parser that accepts. Huh. Select. Okay. They have macros? I didn't even see the macros. Oh, they only have select. Okay. All right. Take until. We use this for the end, don't we? Interesting. I wonder if we should have used this with the fence. I was hoping they had some sort of negate, right? Everything here just seems so positive. I don't know. Because really we want to capture the text as long as it's not anything else. If it's not an emoticon and it's not a code block, text. Right? The ignore function seemed to drop what was ignored. Oh, none of? Wait. Ooh. That's just for inputs. Oh no, that's not it. I had my hopes up. I was hoping it could be a parser. Just filter map filter end empty custom. Yeah, custom is hard because the documentation sucks. You give it a function, right? So let's say let text equals custom, right? Then we get a function. All right, so some value, don't know. Right. And we return something. And if we look at, here, let's clean that up a little. Boom, okay. And in this case, what do we expect f to be? Right, f is a function, custom f. How is it called? Self.0.clone. Oh, here we go. Parse inner. Right. It's getting past a stream. Okay, so then we need to know about streams. And what does it return? A P result. What is this? Vector? Oh, it's the tuple, right? It's our standard sort of error or return type for these. That seems like a stream. Type annotations needed for custom. I'll bet you do need type annotations. Okay, what about... I don't even know if that's available to us. Result? Do they have P result? This is the closest we get. Okay, and let's go back to our parser. Oh, here we are. Text. Now this is custom result. This is going to be what? Was a tuple of vector. I'm just going to say vector of char or... Oh, goodness, I don't remember. It's this, right? What is located? Is this even available to us? It is. I and E, yeah. I, in this case, I think is, oops, message part. E, some error. And what was O? Or was O the message part? Uh-oh. Oh, input and output. Okay. So we got that wrong. Input is char. Output is message part. And E, I don't know what error is here. Oh, that's error simple char. It's this one. Okay. Okay, so syntax error expected semicolon. Oh, here, sure. Mismatch types expected tuple. Yeah, we haven't done that yet. And how do you even produce a located thing? And these are pub crate. We can't do anything with this. Here, okay, here we go. Create a new located with the given input, position, and error. Okay, what if it's located an error? You shouldn't need to interact with this type during normal use of the crate. Yeah, okay. I hear you. And that's really cool. It's cool that they're prioritizing errors, right? Something could be a warning, something could be, you know, less than that, but here. I see. So this is because it might be recursive, right? These are maybe pre-existing. And then here's your result. Here you have a message part with an option to an error, or, excuse me, yeah, or the error. I see. So maybe this is a soft error. Yeah, it would be nice if there was more documentation on this. All right, so if we, I don't know, due to the lack of documentation, I'm going to shelve that. Way down at the bottom. Okay. What about filter? Let text equals we need something that doesn't match filter, excuse me, emoticon or code block. Yeah, back on the shelf with that silly thing. How do we want to do this? Filter. What do we get? We get value, char, what? Expected bool found unit. Okay. Oh, we get to. Yes, we return a bool. So let's say false. Right. Want my curly braces. Type annotations needed. Do you really need a type annotation? Can I just give you a wrong one and you'll tell me what the right one is? Mismatched type arguments. Look at that. Okay. It's expecting, I think, char. What? Still? F takes... Oh, a reference to I. So it's borrowed. Huh. I thought filter would... Is it because we're not using it? Or text. We'll map that to message part, text. Sure. And now it knows the type for it. CH isn't used. And now we're stuck with a problem that we don't know how to match 3 backticks here. We could have a maybe. And we can't match emoticons. Maybe we just have chars. Okay. String. Char. If we can't find it, and then we just have to post-process all the chars back together. What's our rule here? I don't know, any dot map part char. Okay. Charizard. Yeah, luckily, we can collect that into a string. And this, yeah. I think we'll have to post-process that. Okay, let's see what happens. Let's see. What's going on here? At least it's not expecting nothing. That's, all in all, an improvement. Alright, so we have hello. This is a test. Fine. That could all be combined into, text. But what about this one, right? This is text and code, right? Look, it did a code block. Oh, amazing. Okay. I think we found our way out of this forest. Right there. That's it. We just match single characters. We just collect those. Then at the very end, make a string. Wow. And I think we missed opportunity for language developers. Yep, over 2 lines. I've noticed that too. I want to fix that. I've yet to make an issue for it, because I think what I'm going to do is have the emotes be smaller. Right now they're like at 2x size, because I want them kind of in line. And then when we do like single emote messages, those will be larger. So, okay, I think this is our way out of that twisty maze. Because emoticons, we should be able to match a span. So we have to build up the spans, and then we need, what'd you call it? Charizard. Yes, Charizard. We might just have that. And we need this. This is not going to be public. Flat emote? I don't know. Whatever. This one should just, I feel like because char's in here now, we need like our own little internal message part. Right. Let's call it, part, section, span, message span. Call it part. And that's not public. Which means we don't need to serialize it, but we will need to convert it to something else eventually. Okay. What? What are you whining about, Kevin? Oh, I deleted too much on the part. We do need... Okay. go. Okay. Oh, goodness. I gotta run off to work, y'all. Oh, and thank you for the follows. Crosbow, Alvaro, thank you. If you're still in chat, I appreciate that. So, we know our way out. We need to collapse the chars into strings. Right, these here. We also need to match the spans into emoticon spans. And then this should work. Okay, let's clean some of this up. Ours will never be used here. Ever. Alright, emotes, not used yet. And then, whoa, all this. I think it's lying. These are, oh, they're not constructed in my project yet. And that's okay. We'll have some sort of hub function parse that'll take some sort of message, which is a vector of char, and we will also need emotes. And emotes here should be, what should that be? Here? Because I don't think we're going to use flat emotes the same way. So we'll have to figure that out. Unit. We will return a anyhow result of back message part. Need to do that. That'll convert the emotes into a hash map of maybe we should take a hash map. So I'd hate to do that. No, we have to do that. We have to do that. To a hash map of span to ID. Where's the message? Combine part char into message parts text. Perfect. All right. So this is on the docket for tomorrow. I gotta run. Ooh, that feels like we made progress. That's good. I like learning about Chomsky. It's interesting, and I think our use case is, dare I say, unique. So video object store API in Rust. What it? Interesting. Heavy to make it. Oh, vampire survivor like. I haven't. Okay, there's a couple people we have never rated and I've never watched before. Ed shot 6. Huh. All right, y'all. Till next time. Take care.